draw the normal here, and if this is the angle of incidence, by geometry this is also angle of incidence. This is angle of refraction, and this is angle of refraction, and this same is the angle R here, because this is 90 degree, and this is what? This is the 90 minus R. So that's why this is R. So in this way, and we take this name of these 2 points also, C and D. So again, this is what? This is again the partition between A, B, C, and this is a B, D, C. Okay. So for the proof of law of refraction, we take the 2 triangles here. First of all, take triangle ABC. In this triangle, angle I is the incident angle, which makes a incident wavefront with the refracting surface. So here, sine of I, this is equal to perpendicular by hypotenuse, and here is the perpendicular is what? Because here is the becomes a 90 degree, and here is the one angle. So this becomes a base, this becomes a hypotenuse, and this becomes a perpendicular. So here it is AC divided by BC. And for angle R, we take triangle BDC. In BDC, sine of R is equal to, again perpendicular by hypotenuse, and this is equal to, here this is a 90 degree, here is the angle R, this becomes a base, this becomes a perpendicular. So BD here perpendicular, and again BC is the hypotenuse. So therefore sine of I divided by sine of R, and this is equal to AC divided by BC divided by BD divided by BC. BC and BC in the denominator, so we cut this 2. So AC is what? AC is V1T, and VD is what? B2T. So T and T cancel.